Hello guys, welcome to another session of Niger Hack. So today we'll be taking a look at the recent window print spooler vulnerability that was discovered like about a week ago. But currently Microsoft has released a patch, so it's important that we all patch up, all right? Because this vulnerability is very critical because it affects all window-based operating system, not just client, but also server-based. And also it affects the domain controller that hosts your Active Directory. So you can see how important this is. So let's establish a few information about this vulnerability before we go on to our lab. So you can see the vulnerability can be used to carry out local privilege escalation and also remote code execution. And it is commonly called PrintNightmare, right? So for local privilege escalation, an attacker can go from, having a low privilege user account to having a domain admin account, so escalating his privilege, to carry out some other sophisticated attack. Now, so for remote code execution, which we'll be doing today on our lab, the attacker can install programs, delete data, and also create new accounts with full admin rights, that have system level privileges, right? So like I said, this vulnerability is critical because it affects all Windows-based operating system, right? Even down to the latest version of Windows. Why? Because it's leveraged on the Window Print Spooler Service that runs by default on all Windows-based operating system. So if your system currently is running on your network, is running the Print Spooler service, right? And you've not patched up, that means you're vulnerable, right? I'll explain that later in details. But so this is how our lab scenario look like, right? So this is our lab scenario where we have an attacker machine, right? Then we have an application server and we have an Active Directory. So our target today will not be the Active Directory. We'll be looking at how we can exploit a remote application server. So first of all, our goal is to scan to see what endpoint, what machine on our network is vulnerable, then how we can exploit that vulnerability. So just a minute, then we'll go on to our lab. So guys, this is our lab where we have our attacker machine and also we have the application server that we are going to exploit. All right. So, but first of all, we need to scan our network to look out for what machine is vulnerable, to this exploit. So we have a Python script. So I'm just going to move on to the location of where the script is. Okay, so I have the script here on my desktop. I'm just going to, since it's a Python script, these days most Python script run using Python version 3. So I'm just going to state that 3, then name of the script is detect PrintNightmare. So right, so I'm going to have that detect nightmare. Yep. .py. All right, so the script has several other arguments. All right, so let's check out for what else we can use. So okay, so we can use -t for if we want to specify a single IP address. So if we have a list of IP addresses, especially within the corporate organization, we can put those IP addresses in a text file and scan, right, to see. Especially this script is very useful, especially even once you have patched up and you still want to confirm if there are system outdated on the network that are still vulnerable to this exploit, right? So we can also specify a host subnet, right? So using -c, which is what I'm going to do, right? So I'm just going to repeat script, then .c, then my network is 8.0. So 192.168.8.0. Then my subnet match. So I'm just going to wait for a while, let it scan the network, right, to see and check if any of my system is vulnerable. Of course, this is the first stage of the attack keychain. You have to perform some sort of scanning so that you have a focus exploit, not just going out to see, checking on every machine that you find. You want to know which of them is vulnerable first before you can perform your exploit. So while this is running, let us take a look at how this malware work, the workflow. So I think I have so we have this is okay. So this is a slide that shows how it works, right? So we have the CVE, which is 2021-34527, right? So it checks if the Spooler service is enabled, which is let me show you guys. So it's by default, the printer Spooler service run on every Windows-based operating system. So you can check that by using the services.mfc and check if that service is currently running on your machine. So if that service is running on your machine, that shows some potential vulnerability that you might that shows that you might be exposed to this vulnerability, right? So, but if that service is not enabled, right, it shows that you're not vulnerable. That's what it means. So let me check my system and just look out for Print Spooler. Right, this shows it's currently running, right? So there are other things that the CVE checks for. So it also checks if you're patched, right? If your system is patched. So if it's patched, that means you're not also vulnerable. But if you're not patched, there are also some certain registry settings that the vulnerability checks for to see if they are enabled and they are set to 0. So Microsoft recommends that these registry settings are set to 0, right? Or they are disabled. So if they are set to 0, right, that means you're not vulnerable. But if they are not set to 0, if they are enabled and they are not set to 0, right, that shows that you locally you can be exploited, right? Or on a remote case, on a remote scenario, just like we are trying to establish within our lab, it checks also for the remote printing feature. This can be found within the group policy settings if this is enabled. So a remote system can also be exploited, right? So basically on the high level, this is how it works. It checks for certain parameter to see if you're vulnerable or not, you know. So, and these are the various parameters. First of all, check for the service. Secondly, checks if you're patched. Thirdly, you also check for certain registry key parameters and checks their value. If it's disabled, set to 0. And if not, it also go on to assess if the victim system is local. That means you have you have local access to it, or you want to access it remotely, you know, so it could be exploited, right? So let's go back to check on our scan. So, okay, our scan is still running. Just a minute. So guys, you can see the results of our scan. You can see that .100 is vulnerable to the CVE 2021, right? 16.75. So you can also see .102 is vulnerable, right? So this is helping us to having some sort of targeted way of attack, right? So we don't just go on any system trying to run our exploit. So what I'm going to do next is to generate a payload. Like I said, this CVE works by running a malicious DLL file. So we are going to use the MSF Venom to generate our payload. Then also we are going to host our SMB-Server to load our payload and allow it to run on the remote victim system. So I'm just going to open a new shell and wait for this scan to complete. So the IP address for our victim system is .102, which is already seen here. So guys, moving to the directory where we have our exploit, so which is on my desktop. Yeah. So the exploits can be downloaded from GitHub. I'll drop the link on the YouTube channel, or also we can see it from. So shout out to John Hillman. So this is the local privilege escalation version of the script, right? So we can, once we are able to download this, because he has a link, we can trying to look out for the link where we can download. Let me see. So you can go on to John Hillman's GitHub and check out for this CVE. Yeah. Okay. So this is it. So you can go on to download these on your attacker's machine. So once you download these, then we'll move on to that particular folder. You understand? Also, he has his own customized version of InPacket too, right? So that has this CV embedded in it, which is what I'm using at the moment. So once you've downloaded the InPacket tool from GitHub, then you move and change directory to that to the file or folder. Then you can see this is the CV Python script. So this is the location where we are going to actually generate our payload, right, and also host it on the SMB server. So like I said, I'm going to be using the MSF Venom. So MSF Venom -p to specify the payload. Then it's a window-based payload, right? It's a window-based payload. I'm running 64-bit operating system. Then, of course, MSF Venom works with the printer, right? Then, so because I want to establish a shell so that I can carry out all the activities after exploiting this vulnerability. That's why I want to establish a reverse TCP shell, back to the attacker's machine. So that's why I'm using this specific payload, reverse, it's called TCP, right? So I'm going to state my host machine, which is the IP address of the attacker, right? So which is the IP address of this Kali. So this is 192.168.8.100. Then also the port, you can use definitely just any ports that's open. I'm going to use 444, right? Then I'm going to specify the format of my payload, which is a DLL, right? Then I'm going to show how it is been the output, the name of the output file. So let me just call it see shell. That's DLL. Okay, so basically this is just a basic command to generate payload. You can choose to generate a .tsc file, but like I said, this CVE is exploited using a DLL file. So I'm just going to wait on just a minute so that the file will be generated. So guys, while we wait for the DLL file to generate, our payload to generate, the next thing we are going to do is to host an SMB server, right? That we'll use to host the DLL file. So we have our DLL file right now. You can see messy shell.dll, right? So we're going to host our SMB server, so that we can make this file accessible to this victim, to the Windows Server machine, right? So I want to split this shell so that we can see everything on, on one screen. So I'm going to do split vertical. Okay, so I'm going to go on to the directory. So the in-packet tool can also, just like Metasploit, it also has several payloads, right, that you can use to achieve different functions, right, just like Metasploit too, and most of these payload are made up of Python scripts. So to run, I'm going to use the in-packet tool to launch the SMB server. Right, so that's why I'm going back to that folder part, that location. Yeah, setting. Okay, so I'm going to go back to the location of the CVE. Okay, so this is this location. We are going to launch our SMB server here. To do that, we're going to say sudo in-packet, right, dash SMB server. Then the name of the SMB file share, can call it SMB. Then we'll specify where we want the SMB file share to be located. Like I said, I want, because we have our DLL file here, right? So I want the server to be hosted here so that it will be easy, and it will be easy for the victim machine to have access to it, so for us to also remotely run that malicious DLL file. So that's what I'm going to use. I'm going to be stating the current directory, right? Okay, so guys, you can see we have our SMB server up, right? So the next thing we're going to do is to set up a listener, like we're going to set up a listener back on this victim, on our attacker machine, so that once this file is loaded and it is executed, we'll have a connection to the victim machine. So to do that, to set up a listener, we are going to use the Metasploit framework to do that. So I'm just going to run MSF console, right, to MSF console to launch Metasploit. So, while we wait on for the console to come up, Okay, so guys, this again shows how the vulnerability works on the back end, what exactly is happening within underneath, this vulnerability. So what is the implication? How does it allow a remote user to have access? You can see the major thing about the vulnerability is that it allows a local privilege authenticated user, that is a user with limited access on a system, to install a printer and also allow that user to specify a driver for that printer, from any remote location. Now, during this process, right, it checks that that user is authenticated. So that's one of the major checks, that, okay, this user is authenticated, has some sort of credential, maybe be it privilege or low-level privilege credential to the system. Once that check is done, is that the user is granted a system-level access. So this is where the bug is, guys. Automatically, a user, that has a low privilege rights on the system, is granted a system-level access to install that driver. So this is where attackers be leverage on, to say, okay, since they have a system level access to install a driver on, for a printer, they could also leverage that, to carry out a remote code execution, such as injecting malicious DLL file, creating user, like I said earlier, to install programs too. So this is basically how the exploits work, and how it is being used in the wild. So let us go back, check on our Metasploit framework. So guys, so we have our Metasploit up. You can see it here. So don't mind my screen. I'm trying to make sure that everything fall in just one shell so that we can see how everything, all the activity is working. So I'm going to, like I said, establish a listener. So to do that, I will use multi-handler. Right. So then I'll check on the options that are available for me to configure. You can see we need to set our local host, our local port. These are required parameters. Then also, I think we also need to state our payload, right? So we are going to be using the same payload we use when generating the DLL file, right? So if we scroll up, can do a copy of that payload. You can see we used using the MSF Venom. We generated this this payload, right? That we are going to be hosting on the remote system. So we are just going to stick with the same payload. So you can do a copy, right, and set it there. So on the Metasploit framework, you're just going to set our payload, set payload. So to the reverse TCP, so that we can establish a shell. Right. So now also we are going to specify state our local host. So the local host has the IP address of the attacker, which is 192.168.8.100. Then our ports, set local port, right, to 4444. So guys, I think those are just the major parameters we need to set. So we are going to launch our listener by running the exploit command. So you can see, okay, so we started a reverse TCP handler. Okay, set local hosts. Yeah, so 192 ports. Okay, so now we've set up a listener. we have also our SMB share ready. Then the last thing we are going to do is to run the exploits that we generated, which is this DLL file. So we are going to run the exploits that we downloaded from the GitHub, and we're going to leverage this DLL file that we created here. All right. So to do that, I'm going to open another shell. I'll split this part, guys. Okay, so then I'll move on to the location where we have our DLL file. So desktop directory, desktop in packet, then CVE, so this is the location where we have our scripts. You can see. Then we have also our DLL file that we generated. So so right now we are going to run the DLL file. CVE. So sudo Python 3 because Python 5. Then we have the CVE 2021-1675. No, CVE 2021, right? That's 1675.py. Then, like I said earlier, these exploits requires an authenticated user, so it doesn't matter if it's a low privilege user or normal privilege user. So just about any user that have access to, either to the target machine. So let me show you guys. So this is our target machine. You can see this account is one of the user. It's in target machine. We have other users. You can see we can use just about any of these users to run this text. So right, so I'm just going to state, I'm saying so the IP address of the target machine, which is 192.168, right, .8.102, right. Then we are going to also specify the share location where the DLL file is located on the target machine, on the attacker's machine. Yeah, that's 192.168.8.100, right? Then also specify our share, the SMB location, our SMB location name that we create, that you can see it here. It is stated as SMB, so that is what we are going to state here. Right, so then next is the name of the DLL file, which is message shell. So I'm going to just drop it there, copy and paste. You can see, guys, this is it. So we have the exploits that I told you we downloaded. So you can't carry out this if you don't have this Python script, which is what you are trying to establish, right? So we are trying to see how we can leverage on these two, right, to carry out a remote code execution attack. So like I said, we need to also have an authenticated user, and this is the IP address of our attacker machine, of our victim machine. Then we have to also specify or state the location where our the DLL file that we are trying to load, where it is located. So since we have a listener, don't forget we have a listener currently listening, waiting for this file to be loaded, right, and get some sort of reverse connection from the victim system. So we're just going on to load this. I think is asking for, okay. Just a minute, guys. I think I need to close, okay. This prompt, so I need to close it. So forgot to close the location, then can run this. Should be asking us for our password. So I'm going to specify the password. Right, it's trying to establish a shell. So it's saying that have bad network. Okay, so we are just going to confirm if we can have connectivity to that machine. So let me just check that out. Okay. So this is my IPO. So guys, I'm so sorry, the IP address of the victim machine is actually 101, right? So it's not 100. So I'm just going to update my script. All right. So let's go on back to update. So I'm going to close down my share and we set that to set the host, local hosts to 192.168.8.101. Right, so then confirm all the parameters here is correct. Option. Okay, so we have 101, we have a port, guys. So let me also confirm the payload. So at this point, we are still going to generate a new payload. Why? Because we generated our payload using .100. So it's just going to generate quick a new payload DLL file, with the correct IP address. Just a minute, guys. Okay, so we have this. Let me try and minimize this. I don't want to close our. Oh, okay. So let me just use a different what's it called? Different shell this time. So I'm just going to go to desktop. So to the location, then the CVE, right? Sorry. So we, at this point, can still use back our MSA Venom to create. Use back our MSA Venom to generate the payload. Right, so this time the only thing we are changing is the local host that we specify on the payload. Right, the port is still the same. Then we can just create a new name for our DLL file. All right, you can see Nigeria. All right, so let's leave it as so holding on for payload to generate. So guys, you can see we have our payload now, which is this with the IP address .101. So we can just quickly copy and go back to our exploit. So we are just going to repeat this. Don't forget we have I'm going to repeat this. Let me try and clear the session. Okay. So what we're just going to change the IP address of our shell folder to then also the name of our DLL file. Paste it. Okay. So fully. Okay, specify our password of the authenticated user. So guys, we're trying to, you can see generating, trying to establish a session. So let's take a look at our listener if we have, okay. So we are going to run that again. We forgot to start up our listener. So we can just do it with run, right? So while it's listening, so we're going to run this again. So let me clear my screen. All right. So guys, hopefully we're able to establish a listener. See the server. You can see sending stage. Guys, you can see we have our listener right now. We've established a session. We have one session open. So what does this mean? This means that we can remotely access or run any form of command, upload files, delete data on the remote system. So for that, I'm just going to show you the information that we have. Let me try and do it clear. Okay, sorry. I want to make this small. Okay. So you can see, let me do system info. You can see that we are currently logged in onto the remote Windows Server, the victim machine, which is Windows Server 2012. Look at the information. If we take a look at what permission we currently have, you guys can see, you see we establish our session. This is what I'm trying to explain to you guys. We establish our session using a normal user account, but currently you can see we are automatically running on the system privilege account. And what this means is that we can run tools to dump credentials, like can do this to dump credentials. So if this is a domain controller, you could imagine the impact, right? Because it simply means that you can dump credentials locally and also the ntds.dit credentials, that contain the hashes that, of all systems connected to the domain controller. So you can see quickly we've been able to, these are the list of systems, users and the hashes, that we have on this machine, right? So, and we don't even need to go on to start looking at on how we can decrypt this hash value. We can use this hash value we can still go on to carry out what we call the parse hash attack, to access all connected system, So if the system is connected to the domain, we can use the parse hash attack, to and the local admin credentials, right, to establish lateral movement, have access to, as much information that we want to gather. So this is pretty it. We can also go on to, load up this CMD, so this is the list of user from the CMD that we have. We can also go on to load PowerShell, from CMD and carry out other, maybe fileless visa attack, as the case may be. So this just shows that we've been able to compromise this machine and we can, do whatever we like, right? So before we go, I would like to say, don't forget, it's important that you patch up. Make sure you you go on to visit the Microsoft site and download the patch. You can, on a corporate organization, you can deploy a patch using your group policy, to ensure that all the systems are patched. And also for systems that are not internet facing or are not able to receive the patch, you can make sure that you disable the, what's it called, the Print Spooler service from running. This is very critical. So if you have systems that are not used for printing operation, just disable this service, so it will save you a whole lot. Because trust me, attackers are looking out to see various ways to exploit this vulnerability. Why? Because it affects all Windows-based operating system, and very few people are aware of what is happening right now. So thank you guys, and watch out for my next session.